Welcome to 2.3's Math Moment. Today's students took what they learned yesterday about decimals and applied it to finding equivalent decimals and focusing more on finding strategies for how they are the same. So, one example says to write each amount as a decimal number. Again, we have a fraction, and then we have a money question, and looking at decimals that are the same. 200. I know that I do not have a whole, so I put a 0 in my ones place. I have my decimal point, and then I know that the first spot is tenths, the second spot is hundredths. I want my 2 to look exactly like it normally does, but I want it to be in the hundredths place to show 2 hundredths. So then I use a 0 in the tenths place to hold the spot. 2 hundredths as a fraction and 0 and 2 hundredths as a decimal are equivalent. The next problem is 4 cents. I need to think about how I can show that as a decimal. When we think about cents and money, we think about place value because 4 cents would be equivalent to 4 pennies. We have 100 pennies in $1 or one whole. So this would just be like 4 cents or pennies out of 100 cents or pennies to make one whole. So now I've shown it as a fraction, let's change it to a decimal. I do not have any whole dollars, and I want it to be a decimal, so I put my decimal point. I want my 4 to be in the hundredth spot. The first spot is always the tenth, the second spot is always the hundredths. I want my 4 to look exactly like it normally does, but just in the hundredth spot to make 4 hundredths as a decimal and to show 4 cents. Another way that we can show students that 4 cents is the same as decimal points is to add the dollar sign and make it look like actual money. This would be the same as 4 cents or 4 pennies. Another problem that students worked more with today is looking at a long list of numbers and deciding which one is not equivalent or equal to the other values. So one strategy that we showed yesterday that we're going to show again today is lining up those decimal points and those numbers. So I have 4 different numbers, so I'm going to line up 4 decimal points. I'm then just going to place my numbers with those decimal points. So I have 0 and 3/10. I have 0 and 300 thousandths. I have 0 and 3 hundredths. And I have 0 and 30 hundredths. Now, the strategy that we've shown students is that you look up to down to see which number is not equal to the others. So when I look down this line, I see all of the zeros are equal and in the same spot. My decimal points are all lined up. I look at the next column and I see I've got 3, 3, and then a 0. That tells me that this decimal point or decimal is not equivalent to the other 3 decimals. Another strategy that students could use is to look at zeros. If there are zeros on the end of a decimal number, they could roll off to make an equivalent fraction. So these 2 zeros could roll off to be that decimal, which is the same as this decimal, 3/10. This 0 could roll off to be 3/10 as well. This 0 here cannot roll off because it's being held in by the decimal point and the 3. So this is the fraction that is not equivalent or equal to the others. Now students can use this same strategy to decide whether decimals are bigger or smaller than another. That strategy works here when I'm trying to decide less than or equal to and compare decimals. On this one I have 0 and 67 hundredths. Here I have 1 and 67 hundredths. Now this one's pretty simple to see that I've got one whole in one of my decimals and I don't have a whole in another. So automatically I know that the bigger decimal is going to be 1 and 67 hundredths, and I'm going to want my sign facing that way. This one gets a little bit trickier. I line up my 2 decimals and I place my numbers in the spots. Using the same strategy, I can see that I've got 2 zeros that are equal, decimal points that are in line. Then I have a 5 and a 2. What's bigger, a 5 or a 2? Well, the 5 is bigger, so automatically this number is the bigger decimal. If you have any more questions about 2.3, make sure to see your math teacher.